All right, next we are converting between rectangular and polar coordinates, and then so we can change coordinates from polar to rectangular by plugging in x. Wait, okay, so we're changing to rectangular. So anytime we have an r cosine theta, we can replace that with x, and anytime we have an r sine theta, we can replace that with y. Or when we're going the other direction from rectangular to polar, we can replace, anytime we have an x squared plus y squared, we replace that with an r squared. And if we need to find theta, we would do the inverse tangent of y over x and then figure out the correct angle based on the quadrant. I'm trying to think. Then there would be no radius if x was 0. Gosh, Adrian, don't make me think about that right now. It's just a disclaimer. Dang it. Okay, we got that in our video. Aren't we excited about it? Okay, moving on. So we're converting each point in rectangular coordinates below into polar coordinates, r theta, with r greater than or equal to 0 and theta between 0 and 2 pi. Use exact values if possible or round to 2 decimal places. Check each answer by converting back to rectangular coordinates. Okay, part 1 of example 8. So we have x and y, we want to find r. So r is the square root of x squared plus y squared, correct? So let's go ahead and find that answer. So 2 squared plus negative 2 square root 3 squared. Now the negative doesn't even really matter because it just turns positive anyway. So we have 4 plus 4 times 3, so 12. So that's the square root of 16, which is 4. So we get a radius of 4. So there's r. Then we need to find theta. So we're going to do the inverse tangent of negative 2 square root 3 over 2 because it's y over x. Here, maybe I should write that down from our previous page. So inverse tangent of y over x. So here's y, here's x. So I do this, the 2's cancel out, so I just get the inverse tangent of the negative square root of 3, which is what angle? What angle gives us that? So that, okay, yes. Now, before we select that as our final answer, let's sketch a quick picture. So 2 is a positive 2 x value, and negative 2 square root 3 is a negative y. So that would be in quadrant 4. Well, guess what? That does work. However, let's look at this requirement right here. The requirement is that r is positive. We got a positive r value, 4. But our calculator gave us a negative angle for the tangent value because that's where inverse tangent exists, is the negative value for quadrant 4. We don't want our angle to be listed like that. We want it to be a positive angle. So what is the positive angle? Add, no, because if we add pi, we're in quadrant 2. This has to be a quadrant 4 angle because of the graph. Exactly. Yeah. It has to be 5 pi thirds. Adrian, do you understand why it can't be like 2 pi thirds? Because the point itself, when we graphed it, was in quadrant 4. So the point would be in the wrong place if we used the 2 pi thirds, correct? So our final answer, r theta, is 4 5 pi thirds. We just changed our rectangular point into a polar coordinate point. Whew, number 2. So r is square root of negative 3 squared plus negative 3 squared. I don't want to write the negatives. So that's 9 plus 9 is 18. So square root of 18, which is 9 times 2 is 18. So that would be 3 square root 2. So there's r. And then tangent, inverse tangent of -3 divided by -3 would be the inverse tangent of 1, which would be what? What number gives us a tangent value of 1? Pi fourths, right? I didn't do what? Oh, oops. I did not. I ran out of space. Okay, so now I'm going to sketch a graph of my rectangular point, which is a -3 and a -3. So that's actually in quadrant 3. So is pi fourths the correct angle? No, the correct angle would be 5 pi fourths because it's quadrant 3, and I know that because I graphed it. I graphed the point x equals -3 left, y equals -3 down. That's a point in quadrant 3, so the angle has to be 5 pi fourths. So we get radius 3 square root 2 and angle 5 pi fourths. Okay, you can do this in your head. I just am not doing that in my head because I'm making it very clear about what you need to do. Make sense? Okay, so now, as Adrian pointed out, we're supposed to check our answers by converting it back. Okay, so here is the angle in these coordinates, and we want to change it back to x and y. So for x, we would do r cosine 5 pi thirds. Oh, but r is 4. So, do you see how I'm using the other formulas this time to go backwards? So 4 cosine 5 pi thirds, because this is r and this is theta. So that would be 4 times the cosine of 5 pi thirds. What is the cosine of 5 pi thirds? That would be the fourth quadrant, so it's positive, and cosine of pi thirds reference angle is 1/2. And half of 4 is 2. So there's x. And then y would be our sine theta. So we do 4 times the sine of 5 pi thirds. And the sine of 5 pi thirds is negative square root of 3 over 2. So we get -4 square root 3 over 2, which is -2 square root 3. And that's our y value. So then our xy value is 2 comma -2 square root 3. Check that with our original problem. Ta-da. Yes. All right, so let's go ahead and check question 2. So for x, we're going to do r cosine theta. So we do 3 square root 2 times the cosine of 5 pi fourths. 5 pi fourths is in quadrant 3. So 3 square root 2 times the cosine of 5 pi fourths would be -2 square root 2 over 2. So we're going to simplify that. 3 times a negative, 3 square root 2 times negative square root 2 is going to be -3 times 2, because square root of 2 times square root of 2 turns into 2. And then in the denominator, we still just have that 2. And then our 2's cancel out, so we're left with -3, which is our x coordinate. And then our y coordinate will be our sine theta. Same exact thing happens here. So 3 square root 2 times the sine of 5 pi fourths, which is 3 square root 2 times negative square root of 2 over 2. We just barely did that problem, and we got negative 3. So we get the points back again. Okay, so the whole reason it's telling you to convert back to rectangular coordinates to check these is so that you are doing the process two ways, but that avoided them being actually putting two sets of examples in the textbook so that you're doing them all at once.